In scenarios involving multiple occupancies within a single building, supplied by a shared service with one main disconnect and individual feeders extending to each occupancy equipped with an equipment grounding conductor, the utilization of Section 250.104 A2 concerning metallic water pipes as grounding electrodes becomes relevant. Given the provision that each occupancy possesses its own independent metallic water supply and meter, directly sourced from the municipal supply through underground installations without traversing the building's interior, the applicability of 250.104 A2 warrants careful consideration. Section 250.104 A2 of the National Electrical Code addresses the use of metal water pipes as grounding electrodes. It stipulates specific conditions under which a metallic water pipe system can serve as a grounding electrode. Firstly, the water pipe must be electrically continuous. This means that all sections of the pipe are connected to each other in a way that allows electricity to flow freely. Secondly, the water pipe must not be in contact with the earth. This requirement is to prevent the water pipe from becoming a source of ground faults. Thirdly, the water pipe must be supplied by a single water service. This means that the water pipe must be connected to the city water main by only one connection. In the context of the described building configuration, where each occupancy is served by its own distinct metallic water supply, independently sourced and meted, the conditions of 250.104 A2 may initially appear to be satisfied for each individual occupancy. Each occupancy's water pipe is electrically isolated from the others and connected directly to the municipal supply. However, a critical consideration arises from the fact that the metallic water supply to each occupancy does not physically pass through the building structure itself. This external routing introduces a potential conflict with the overall grounding system of the building. The primary purpose of a grounding system is to provide a lower impedance path for fault currents to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers and fuses. This ensures safety by quickly de-energizing a faulty circuit. When a metallic water pipe is used as a grounding electrode, it becomes part of this grounding system. If the water pipe is not properly isolated from the building's grounding system, it can create a situation where fault currents can flow through the water pipe. This can create a shock hazard if someone comes into contact with the water pipe while a fault is present. To mitigate this risk, a non-metallic isolation section is typically installed in the water pipe. This isolation section electrically isolates the water pipe from the building's grounding system, preventing fault currents from flowing through the water pipe. The necessity of a non-metallic isolation section stems from the need to prevent unwanted current flow between the building's grounding system and the external metallic water pipes. Without such isolation, the water pipes could become a path for ground fault currents, potentially leading to corrosion of the pipes or, more critically, creating a shock hazard. The non-metallic isolation section serves as a dielectric barrier, interrupting the electrical continuity between the water pipe and any grounded building components. While each occupancy's water supply is independent and meets the initial criteria of 250.104 A2, the absence of a direct connection between the water pipe and the building's grounding system necessitates the installation of a non-metallic isolation section. This is to ensure that the water pipe does not inadvertently become a conductor for fault currents originating within the building's electrical system. Therefore, it is indeed advisable to engage a qualified plumber to install a non-metallic isolation section on the metallic water supply of each occupancy. This measure provides an additional layer of safety by preventing the metallic water pipes from becoming a conduit for electrical faults, aligning with best practices for electrical safety in multi-occupancy buildings. In summary, firstly, assess compliance with 250.104 A2, which allows metallic water pipes as grounding electrodes if electrically continuous, not earth contacting, and single service supplied. Secondly, recognize that independent water supplies per occupancy, though seemingly compliant, require isolation due to external routing. Thirdly, prioritize safety by installing non-metallic isolation sections to prevent water pipes from conducting fault currents. Fourthly, involve a qualified plumber for proper isolation section installation, ensuring electrical safety and code adherence. Finally, understand that the goal is to prevent water pipes from inadvertently carrying electrical fault currents, safeguarding against corrosion and shock hazards. The nonmetallic isolation section plays a crucial role in preventing the flow of stray electrical currents through the metallic water piping system. These currents, if present, can lead to several undesirable consequences, including accelerated corrosion of the pipes, the creation of potentially hazardous touch voltages, and interference with sensitive electronic equipment. Corrosion is an electrochemical process that occurs when a metal is exposed to an electrolyte such as water, and an electrical current flows between different points on the metal surface. The current causes the metal to dissolve at the anode, leading to the formation of rust or other corrosion product. Stray electrical currents can accelerate this process, causing premature failure of the water pipes. Hazardous touch voltages can occur when a metallic object, such as a water pipe, becomes energized due to a fault in the electrical system. If a person comes into contact with the energized object and ground, they can receive an electrical shock. The severity of the shock depends on the voltage and current, as well as the person's physical condition. Interference with sensitive electronic equipment can occur when stray electrical currents flow through the grounding system. These currents can create electromagnetic interference (EMI) that can disrupt the operation of electronic devices such as computers, medical equipment, and communication systems. The nonmetallic isolation section effectively breaks the electrical continuity of the water piping system, preventing the flow of stray electrical currents and mitigating the risks of corrosion, hazardous touch voltages, and interference with sensitive electronic equipment. There are several types of nonmetallic isolation sections available, each with its own advantages and disadvantages. Common types include dielectric unions, insulating flanges, and non-conducting pipe couplings. Dielectric unions are commonly used to isolate dissimilar metals in piping systems, such as connecting a copper pipe to a steel pipe. They consist of a fitting with a non-conducting sleeve that separates the two metals, preventing galvanic corrosion. Insulating flanges are used to isolate sections of pipe at flange connections. They consist of a flange with a non-conducting gasket and sleeves that isolate the bolts from the pipe. Non-conducting pipe couplings are used to join sections of pipe with a non-conducting material, such as plastic or rubber. They are available in a variety of sizes and materials to suit different applications. The selection of the appropriate type of non-metallic isolation section depends on several factors, including the type of piping material, the operating pressure and temperature, and the electrical requirements of the system. It is important to consult with a qualified plumber or electrical contractor to ensure that the correct type of isolation section is selected and installed properly. In addition to installing a non-metallic isolation section, there are other measures that can be taken to minimize the risk of stray electrical currents in water piping systems. These include ensuring that the electrical system is properly grounded, avoiding the use of dissimilar metals in the piping system, and regularly inspecting the piping system for signs of corrosion or damage. Proper grounding of the electrical system is essential for preventing stray electrical currents from flowing through the water piping system. The grounding system provides a low impedance path for fault currents to return to the source, minimizing the voltage on metallic objects and reducing the risk of electrical shock. Avoiding the use of dissimilar metals in the piping system can help to prevent galvanic corrosion. When two dissimilar metals are in contact in the presence of an electrolyte, one metal will corrode preferentially. Using the same metal for all components of the piping system can minimize this risk. Regular inspection of the piping system can help to identify and address potential problems before they become serious. Look for signs of corrosion, leaks, or damage to the piping or insulation. Any problem should be repaired promptly by a qualified plumber or electrical contractor. The installation of a non-metallic isolation section is a critical safety measure in buildings with metallic water piping systems. It prevents the flow of stray electrical currents, reducing the risk of corrosion, hazardous touch voltages, and interference with sensitive electronic equipment. In addition to the non-metallic isolation section, other measures should be taken to minimize the risk of stray electrical currents, including proper grounding of the electrical system, avoiding the use of dissimilar metals in the piping system, and regularly inspecting the piping system for signs of corrosion or damage. Consulting with a qualified plumber or electrical contractor is essential to ensure that the correct type of isolation section is selected and installed properly, and that all other necessary safety measures are taken. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations, including grounding and bonding requirements. Adherence to the NEC is essential for ensuring the safety of electrical systems and preventing electrical hazards. In the context of grounding metallic water pipes, the NEC specifies the conditions under which a water pipe can be used as a grounding electrode, as well as the requirements for bonding the water pipe to the electrical system. Bonding refers to the connection of metallic objects to the grounding system to ensure that they are at the same electrical potential. This prevents voltage differences from developing between the objects, which could create a shock hazard. The NEC also addresses the use of non-metallic isolation sections in water piping systems. It specifies the types of isolation sections that are permitted and the requirements for their installation. It is important to consult the NEC for the specific requirements that apply to your installation. The NEC is updated regularly, so it is important to use the latest edition. In addition to the NEC, local building codes may also have requirements for grounding and bonding water pipes. These codes may be more stringent than the NEC, so it is important to check with your local building department to determine the applicable requirements. Compliance with both the NEC and local building codes is essential for ensuring the safety of electrical systems and preventing electrical hazards. Failure to comply with these codes can result in fines, penalties, and even legal liability. In addition to the technical aspects of grounding and bonding water pipes, it is also important to consider the practical aspects of the installation. This includes choosing the right materials, using proper installation techniques, and ensuring that the installation is properly inspected and maintained. The materials used for grounding and bonding water pipes should be of high quality and suitable for the environment in which they are installed. Copper is a commonly used material for grounding conductors and bonding jumpers. It is important to use the correct size of conductor for the application. The size of the conductor is determined by the size of the electrical system and the length of the conductor. Proper installation techniques are essential for ensuring that the grounding and bonding system is effective. This includes making sure that all connections are tight and secure, and that the conductors are properly protected from damage. The installation should be inspected by a qualified electrical inspector to ensure that it meets the requirements of the NEC and local building codes. Regular maintenance is also important for ensuring that the grounding and bonding system remains effective. This includes inspecting the system for signs of corrosion or damage, and repairing any problems promptly. Grounding and bonding water pipes is a critical safety measure that helps to prevent electrical hazards. By following the requirements of the NEC and local building codes, and by using proper installation techniques, you can ensure that your electrical system is safe and reliable. Furthermore, consider the implications of stray current corrosion, which is an electrochemical process that can damage metallic water pipes. Stray currents can originate from various sources, including nearby electrical systems, cathodic protection systems, and even natural sources. These currents can flow through the water pipes, causing the metal to corrode over time. The installation of a non-metallic isolation section can help to prevent stray current corrosion by interrupting the electrical continuity of the water piping system. This prevents the stray currents from flowing through the pipes and causing damage. In addition to the non-metallic isolation section, other measures can be taken to minimize the risk of stray current corrosion. These include ensuring that the electrical system is properly grounded, avoiding the use of dissimilar metals in the piping system, and regularly inspecting the piping system for signs of corrosion or damage. A qualified corrosion engineer can also conduct a survey to identify and mitigate potential sources of stray current corrosion. Cathodic protection is a technique that is used to protect metallic structures from corrosion. It involves applying a direct current to the structure, which makes it the cathode in an electrochemical cell. This prevents the metal from dissolving and corroding. Cathodic protection systems are commonly used to protect underground pipelines, storage tanks, and other metallic structures. However, cathodic protection systems can also contribute to stray current corrosion if they are not properly designed and maintained. The stray currents from a cathodic protection system can flow through nearby water pipes, causing them to corrode. To prevent this, it is important to ensure that the cathodic protection system is properly designed and installed, and that it is regularly monitored to ensure that it is not causing stray current corrosion. In summary, protecting metallic water pipes from corrosion requires a multifaceted approach that includes the installation of a non-metallic isolation section, proper grounding of the electrical system, avoidance of dissimilar metals, regular inspection of the piping system, and mitigation of stray current corrosion. Consulting with qualified professionals such as plumbers, electrical contractors, and corrosion engineers is essential to ensure that the water piping system is properly protected from corrosion. By taking these measures, you can extend the lifespan of your water pipes and prevent costly repairs. And to reiterate, the non-metallic section is required to be installed to prevent any electrical flow from the building to the water pipe.